So let's try to understand what this philosophy of the Euler's method is. It's just another way to approximate. So if I have a curve, what you're doing is you're literally, sorry. You're literally just finding a tangent line to approximate a y value of that. Sometimes we find two tangent lines. Let's say I wanted to find that, so then you're going to find, so all you're doing is just approximating a y value, guys, using tangent line approximation, just like we've always done. But this time we're going to do steps. We're going to move away from the tangency point. And the smaller your step size is, the more accurate your approximation is. Cool or not cool?
Cool.
All right, Ramirez, do you want to take care of example 1 for us?
Yes.
All right, you know what? Take care of example 1 and 2.
Where's my take care of example 1 attitude?
Oh, take care of business.
Okay. Hey guys. Oh, let me get up there and I'll say it. Hi guys, I'm Sophia Ramirez. I hope you guys are watching this video and like it. Okay, so example 1. Let y equals f of x be the solution to the differential equation dy dx equals 9x plus 5y minus 4 with initial condition f of 3 equals negative 6. So let's write that down. 3 comma negative 6. Oh, I didn't even get a calculator. Yeah. Okay. Or do you want me to use the one that you have, the computer one?
Lower the thing. Just push.
Oh, okay.
And right there.
Okay, cool.
It's going.
Okay, I'm going to just use first until now. Okay. What is the approximation for f of 11 obtained by using Euler's method with 2 step sizes of equal length starting at x equals 3?
Okay, underline 2 step sizes.
Okay, 2 step sizes. I'm going to circle it. Okay, perfect. So 11 minus 3 is 8. And so that's the distance between 3 and 11. But there's 2 step sizes, which is just the amount of steps that we have to take in order to find f of 11. So we divide that number by 2, which is equal to 4. So our step sizes are equal to 4 each.
It's fine.
Okay.
It's just that 11 minus 3, which is 8, but then you should do a new line, 8 divided by 2, which is 4, because 11 minus 3 is not 4. All this is linked.
Okay.
You know
Sorry, King.
Oh, we're good.
There we go. 8 divided by 2 is equal. Oh my god. It's equal to 4. Okay. Moving on to the cal stuff. So we have this initial condition, and we're going to find the, slope dy dx of this initial condition. So dy dx at 3 comma, oh my god, your thing is so hot. 3 comma negative equals 9 times 3 plus 5 times negative 6 minus 4, which is going to be equal to, let's bust out the calculator. So 9 times 3 plus 5 times negative 6 plus, what's the last one? Minus 4, so it's not plus. Minus 4. Negative 7, let's go. Okay, negative 7. So that is the dy dx for the equation, and now we have enough to write equation in points of phone. So y minus or plus 6 has to be equal to the slope, or I guess the dy dx, which is negative 7, x minus 3. So let's just move the y. And now we're going to solve for when f is the first step size. So 3 plus 4 is 7. So we're going to solve for when f equals 7. And we got that because we're starting at x equals 3. So I'll write that to the side. 3 plus 4, which is the first step size. And then we're going to plug it into our equation that we have, which is equal to negative 7 times 4 minus 6, which is negative 34. Negative 28 minus 6. Yeah, negative 34. And so now that was the first step, but we have to get to f of 11, so we need to do this all again one more time. So now we have this new coordinate point, which is 7, comma, negative 34. And don't be scared if you get crazy numbers. Oftentimes, Euler's method has long numbers. So we're just going to do the same thing we did again. dy dx at 7, comma, negative 34. It's equal to 9 times 7. Oh my god, it is so hot. Plus 5 times negative 34 minus 4. Okay, let's bust out the calculator. Negative 111. I was going to say 111. Oh. Negative 111. Okay, so that's the slope. So we're just going to do the same thing we did and put that into equation form. So y plus 34 is equal to negative 111 x minus 7. So just move that over. And now we're going to do the last step, I guess you could say. So we're ultimately going to get 11. The way that you know this is that we said that our step size was equal to 4, and last time we did 7, so that's going to equal 11 because 7 plus 4 is 11, and that's actually going to be back to what we have to find in the first place. So this is the last one that we have to do. That's an ugly 7, sorry. And so that's negative 111 times 4 minus 34. I'm going to see what that is in the calculator. Negative 478? Did I do that right? Yes. Negative 478. So that is the final answer. So using Euler's method, the approximation for f of 11, and this is an approximation, so maybe I should actually put this into like, boop, it's approximately negative 478. Let's go.
You want to do example 2?
Yeah, I know both of them. Bova. Sorry, I don't think you might have to cut that from the video.
Only they're untouched. It's funny, you know?
Okay. Alright, so same thing we're going to do. Let y equals f of x be the solution for the differential equation dy dx equal to negative x minus 8y plus 8 with the initial condition f of negative 5 is equal to 1. So I'm going to write that down. That's our initial point. What is the approximation for f of negative 15 obtained by using Euler's method with two steps, sizes of equal length, starting at x equals negative 5? So the distance between negative 15 and negative 5 is 10, but we have to make sure that they're negative because they're both negative and we're going to a more negative value, I guess. So the step sizes are going to be equal to negative 5 because negative 10 divided by 2 is equal to 5. Or negative 5. Whoop. Okay. Alright, let's find the dy dx for this initial point first. It's so hot, Chavez. Okay. Like, I'm sweating. Okay. So the way that I'll do this is just that this is 5, and then these two cancel out because negative 8 plus 8 is 0, so that's 5. So writing the equation using the point and the slope, point slope, y minus 1 is equal to 5 parentheses x plus 5. Move that over to get y by itself. So we're going to use the first step size, which we know is negative 5. from the starting point, which is negative 5. So that is going to be f of negative 10, because negative 5, which is the starting point, minus 5, which is our step size. So then that is 5 times negative 5 plus 1, which I can do in my head, and that's negative 24. So that's our first point. We have to do one more to get our approximation for f of negative 15. So I'm going to use that point again to find my dy dx. This is a bit of a crazier number, so I will be needing a calculator for this. Was that right? Let me see. I am right. Okay. Enter. 210. That's what I got last time, so that makes sense. Okay. 210. So then, putting that into formula or equation again, so that's y plus 24 equals 210 over x plus 10. So then, times x plus 10. Y is equal to 210 x plus 10 minus 24. And then the last y that we are going to use is f of negative 15, because that is the final destination that we need, final approximation, and also negative 10 minus 5 is negative 15. So 210 times negative 15 plus 10 minus 24. So that's 210. Well, I guess I should put a little approximation thing. Oh, that's ugly. Minus 24. So I'm actually going to put that in the calculator because I do not know what that is. Oop. Oop. Negative 1074, which is what I got last time, so that helps me a bit. And there we go. The approximation for f of negative 15 is negative 1074.
Good job, miss. Well, we're about to start a free response, but I guess, yeah, go ahead, I'll pause it.
I'll be very quick. You do have studies on it.
All right.
But by the time your parents got here, it was school. That's what oh, Slay, that is so true.
All right, guys, here we go. How is it going to look on the AP exam? Well, here it is. This question is from the 2007 Form B exam. I don't think you guys will have any trouble with letter A. Letter B, there might be issues with the algebra. We'll do it together. And then C and D are the Euler's Method deal. So let's see if you guys can do letter A. Take like 2 minutes, and then we'll do letter A together. We'll look at the rubric for this in a little bit, too. What do you think? No, tell me. You might be right.
I just took oh, sorry, never mind. No, it's on.
Okay, keep going, Wasan.
Oh, yeah, I would have never called you. I want her to know. Should I tell this? Should I put this back in?
Definitely.
Okay.
I think I know what you're talking about. You like putting the dy dx?
Yeah.
Yes.
Okay.
They want the second derivatives in terms of x and y. And keep going if you haven't finished. So you take the derivative first. So 3 plus 2 dy dx. And then you're not done because they want the derivative in terms of x and y, correct? So you plug in this expression in for that. So 3 plus 2 times 3x plus 2y plus 1. And I guess you could leave it alone if you wanted to, but don't. So here it is. My second derivative with respect to x is equal to 3 plus 6x plus 4y plus 2. I would fix this 6x plus 4y plus 5. Did everyone get that? Okay, can we do that? All right. Take about 3 minutes. Yes. You didn't get that? You took a derivative, right? The derivative of 3x is 3. The derivative of 2y. Oh. Yeah, because that's a constant. So it goes away. All right, take 3 minutes, guys. See if you can figure out letter B. It's algebra. Did you get an answer for this, guys? All right.
I got an answer for 2.
What'd you get?
For M, I got -3.
I don't know the answer yet, so I don't know. Maybe you're right. Let's see. Let's see what I'm going to do. Let's see. Okay, here's what I would do. You see this dy dx? I'm going to write it here somewhere. dy dx equals, what was it, 3x plus 2y plus 1? And then I see, let's find the values of the constant m, b, and r for which y equals the solution to the differential equation. Well, if I want it to be a solution, that means dy dx equals m plus r e to the rx. Does that make sense to you guys? It's a constant. It's a constant.
Oh, so you took the derivative of that.
I mean, that's the only way I
Why did you
can.
put R?
I did. R E R X. It's right here.
Okay, then I definitely. Oh, okay. Hold on.
I mean, I could be wrong. I haven't done this question yet, so we'll look at the rubric together and see what's up.
Yeah, but I think.
So, yeah, here's the connection that I see. I see that they gave me a dy dx, and I see that they gave me a y. So in my head, I'm thinking the only way these are connected is if I take the derivative of this and equal them to each other. Does that make sense? So I'm going to write m plus r e to the rx better equal 3x plus 2 parenthesis. It says y. I'm going to write mx plus b plus e to the rx, close it, plus 1. That's what I see. Oh, because it says y, and this is y.
Oh, I got you. Let him put. No, I think, yeah. Yeah, I think you're cooking, Charles.
What does that mean, cooking?
Like you're doing it. Like.
Oh, I mean, I hope so.
That's why I said you're a calculus.
Oh, but even if I don't know what I'm doing, I feel like I have an idea.
Okay, yeah, that's what I'm saying. You have an idea.
But so do you, because you're pretty smart. But I better delete that from here though.
Oh my god. I don't think you're weird him.
2mx plus 2b plus 2e to the rx plus 1. Okay, yes. I'm going to rewrite this. I'm going to group that. Okay. M plus re to the rx equals 3 plus 2m. All I did was group.
Oh, okay.
I'm just grouping to make it easier for me right now.
Did you subtract
2b plus 1. No, don't. Because we're trying to figure, you know what I mean?
Yes.
2b plus 1 plus 2e to the rx. Okay, here's what I'm doing. I grouped the 2b and the 1. That's some constant. Okay, I already see what's going on. They're kind of tricky. I think this is heavy level algebra, but that's why they put it in the BC exam. So here's what I think. I don't see any x. Do you see how this has an x, the right side, but the left side does not have an x? So I want to say that this zeroes out, but don't just zero it out by saying x equals 0. You can't do that because it's an x. Like it could be whatever, right? But this here, the 3 plus 2m, that you can say has to equal what? 0, because I don't have an x on the left-hand side. So from there, that's going to give us this. 3 plus 2m must equal 0. Because I don't have an x on the left-hand side. Does that make sense, guys? So let's see. From there, move the 3, divide by 2. M equals negative 3 halves. So there we go. We got an m. Is that what you got? It is what you got? Perfect. Then we're around the, maybe you did it differently and we still got the same answer. All right. Let's see. What else would I do? Yes. Okay. Yeah. So now here's, yeah, that's what I'm, m is just a constant, right? This is just a constant. Well, look at this. This is just a constant. And I already know what m is. So I can go negative 3 halves, that's your m. That's this one right here, right? Better equal 2b plus 1. Subtract the 1. So negative 5 halves equals 2b. Minus 2, yeah. And then divide by 2. So b equals negative 5 fourths. Let me know if I made a mistake. Is that what you got also? Okay. No, maybe it's the right one, miss. And then last but not least, I have this 2e to the rx and re to the rx. So if re to the rx equals 2e to the rx, that means r equals what? And there it is. We got r. We got r, we got b, and we got m.
So, like, how do you know that, like, m plus r is the rx and 2b plus 1 plus the rx? How do you know that, like...
Because they must be equal. Because they must...
Yeah, I know they have to equal each other, but how do you know that, like, m isn't a number that... How do you know that r is 2? Like,
Oh, well, this is the only...
r was 3, and then 2b plus 1 was just bigger than
No,
m.
well, because the equivalent expressions, this is the only thing that has an exponential. 2e to the rx, what has an exponential? This e to the rx. So this exponential part must equal this exponential part. Like it must. It must. You know what I mean? And then you're right, m is a constant, but I got lucky that I had all this stuff that is also just a constant. And then on the left side, there's nothing that has an x on it. So this x, you can't set x equal to 0, but you can set this expression equal to 0. You know what I mean? Correct. All right, I think we're good. We'll see the rubric in a little bit to see how we're doing with that one. All right, here is the good stuff that I wanted to show you guys. Look at letter C. Let y equals f of x be a particular solution to the differential equation with an initial condition, f of 0 equals negative 2. Use Euler's method starting at x equals 0 with what type of step size? Half, to approximate f of 1. Show that work that leads to your answer. Go for it, guys. Give it a shot. And we'll come back in about 2 minutes. Now, I'm going to go ahead and start it, guys, but you guys keep doing your thing. I got the point 0, negative 2. They want to know 1/2. So I'm going to write dy dx. And I already forgot what my dy dx was, so I have to scroll up here. 3x plus 2y plus 1. Okay. 3 times 0 plus 2 times negative 2 plus 1. Let me know if I make mistakes because I don't want to make a mistake right now. 2 times negative 2 is negative 4 plus 1 is negative 3. Did you guys got negative 3 as your first slope?
Yes.
Okay. Y plus 2 equals negative 3. X minus 0. I'm going to plug in a half. So y equals, or f to the half equals negative 3. times a half minus 2. What's that? So negative 3.5 minus 2, that is, turn that into 4 over 2, 4, 5, 6, 7, negative 7 over 2. All right, so now my new point is 1/2 comma negative 7 over 2 dy dx equals 3 times 1/2 plus 2 times negative 7/2 plus 1. 3/2 minus 7 plus 1. 3/2 minus 6, so 12 over 2. 12 and 3, 1, 2, 3. Yeah, negative 9 over 2. And that's my slope. So here we go. Right over here. Y minus 7/2 equals negative 9 over 2. X minus half. So f of 1 equals negative 9/2 times a half plus 7/2. So negative 9/4 plus 14 over 4, because I multiplied it by 2 over 2.
No, minus 7. It's negative 7 over 2 because y.
Oh, yes, yes, yes. So I messed up. Where did I mess up? Right here? Yeah, plus, and then this is minus. Yeah, sorry guys. I would have gotten it wrong. Yeah, minus, so that's going to be 14, 24, 23. Negative 23 over 4. That's my approximate, so I should put approximate. All right, that I should have probably put some more space in there, but I think we're good. Did you guys get that?
Yes.
Okay. Let me read letter D. Condition. Okay, you're still using the same differential equation then. Euler's method starting as side of one gives it. Oh, you're going backwards. I like it. Okay, see if you guys can do letter D, guys. I like it. You're going backwards now. But it's the same. You can start at the same. You don't have to go backwards. Just start at the same and get the K values. You got an answer? I'm just going to start it, but I'm not going to finish it. Let's see. The initial point is 0k, so that k is my y value with a step size of 1. Okay, so dy dx equals, let me get it from over here. You're still using the same differential equation because it's still a solution. So 3 times 0 plus 2 times k plus 1. So you get 2k plus 1. Right? And then, let's see, y minus k equals 2k plus 1, x minus 0. And then this is what I'm using to approximate, and I already know what the approximate should be. It needs to be 0. You guys know what I'm doing, guys? Okay, so let's see. So here's what I have. Y equals 2k plus 1 with an x on the side plus k. Yeah. So here we go. So I know this, 1 comma 0. So yeah, 0 equals, parenthesis, 2k plus 1 times 1 plus k. Drop the parentheses. 0 equals 2k plus 1 plus k. So 0 equals 3k plus 1, right? And then move the 1 to the other side. So negative 1 equals 3k. Divide by 3. So k equals negative 1/3. All right, should we check our rubric? All right, let's check our rubric, guys. I haven't checked this rubric, so it's going to be new to all of us. Come on, buddy. Math Live, Calculus, College Board, Response, BC, Scoring Guidelines, 1B. All right, let's see. What question was it? 5? Yeah. Okay, 2 points. Letter A. I take the derivative, 3 plus 2 dy dx, which we all did, and the answer, 6x plus 4y plus 5. Did we get that? Okay, letter B. Taking the derivative of y equals mx plus b plus e to the rx, you should get m plus re to the rx. We got that? value of R is R equal to value of M and B is 1 point. Does M equal, where are you, M? Negative 3/2. And does B equal negative 5/4? We got it. It says here or. Oh, I guess they're, hey, didn't you get a different value?
I got a half.
Yeah, they got a different, if you said R equal to 0, they got negative 9/4. I didn't even think about that one because I didn't do that route. They said R equal to 0, I guess. Yeah, I'm not.
Two different values.
Well, I guess if you said, see, this one R does not equal 0, and this one they set R equal to 0. I don't know. I have to look more into it to see why they set R equal to 0. Is there a specific reason why you would?
Because they wanted the B to be 1.
Hmm.
Then it said the B to the R as 0. Then it'd be 4.
See, but okay. Well, we'll look at that.
1 on one side and then 2 on the other side.
Yeah, we'll look at that later. Here's a formula, guys, which would work, but I don't like the formula. I think it's just better to do it the way we know it. F of 1 equals, did we get negative 23/4? Yes. Letter D, did we get K equals negative 1/3? There it is, we got it. So I would say that you guys do you feel like you're pretty good at Euler's method? Okay, so we got 2 more questions to do, and I'm going to hook you guys up. Don't look at the rubric, grade yourself, of course, once you finish. And that's what we'll call it a day there.